everyone. My name is Michelle.
My name is CHARISSA HAZEL.
Today we'll be talking about the periodic table.
We're going to be talking about group 1 metals, aka alkali metals, and then we're also going to be talking about halogens and transition metals and also noble gases. Yes. Put your sandwich down first. Let's get started.
Okay, so now let us get to the presentation itself. So today we'll be presenting about the periodic table by yours truly, Michelle, REVINA, and CHARISSA HAZEL.
Okay, so first of all, we have to know a little bit of the history behind the periodic table. So the periodic table of elements is founded by Dmitry Mendeleev in the year 1869, but sadly, Dmitry Mendeleev died during the year 19...
Okay, so we had a little bit of an intermission break a while ago, but now we're back and we'll continue on with the presentation. Okay, so first we'll be defining and also explaining a little bit of the function of the periodic table of elements. So, the periodic table is a way for scientists to organize the elements for easier classification and access when needed. The periodic table is organized by increasing proton number. Groups are the columns going down, representing the same number of valence electrons of each element. And elements put in the group also have same chemical properties. That's why hydrogen aren't called group 1 alkali metals, but we'll get into that. And periods are the rows going sidewards, representing the same number of electron shells. Now, more information regarding how elements are organized. Generally, the metals are from group 1 to 3. 4 up to 7 are considered non-metals, while 8 are noble gases. Then we'll get into that a little later. Transition metals are between groups 2 and 3. But to be more specific, a zigzag line is usually drawn to separate the metals and non-metals.
Okay, so to help you guys visualize a bit more about how the periodic table is organized, like what Michelle said, the groups going down have the same chemical properties and also have the same number of valence electrons. So hydrogen here isn't considered a group 1 metal because it's not a metal, it's simply a gas. But they do have the same number of valence electrons because hydrogen only has 1 valence electron, right? That's why it's still considered group 1. It's still put in the same row as group 1, but it's not a group 1 alkali metal because it's a gas. And the periods are going sidewards. They are organized by the amount of electron shells they have. And like what Michelle said, they're separated by a red zigzag line too to separate both the metals and the non-metals.
Okay, so now we'll be diving deeper into the first group, which is alkali metals. Now, some properties of group 1 metals include soft silvery metals. They're usually light, low density, and also low melting point. They only have 1 outer shell electron or valence electron because group number is equal to the number of valence electrons. So they're group 1, they have 1 valence electron. And since they're a metal, they give away electron. They are very reactive.
Another addition to that is that they're very reactive because there's less shielding effect. So going down the group, like the reactivity increases because they have more shells and the distance between the electrons and the nucleus itself gets bigger and there's less forces of attraction between the outermost electron and the nucleus. So it basically is a lot easier for the electron to go to another element to react like that. So it's easier for it to lose an electron going down.
Not only are the reactivity increasing going down the group, but density as well as melting points. Density only increases, melting points decreases going down the group.
Okay, so more about the reactivity of the alkali metals. The most reactive metals in the periodic table are the alkali metals because they only have 1 valence electron. And then for the reaction with water, so basically this is what happens when alkali metal reacts with water. They form a hydroxide and they also form hydrogen gas. And hydroxide, later you'll learn why they're called alkali metals because every product of their reaction with anything, they always produce alcohol. So for example, going down the group, the reaction, because it's more reactive, the reaction is also more violent. So lithium plus water, it floats around the water and a gas fizzes. That gas is hydrogen gas. So lithium plus water, the product will be lithium hydroxide plus hydrogen gas. And then sodium plus water melts into a silver ball and shoots across the water. A gas fizzes, again hydrogen gas. Sodium plus water, sodium hydroxide, which is an alkali, plus hydrogen gas. And then potassium with water melts and shoots across the water. The gas catches fire, the potassium catches fire and burns with a lilac flame. So potassium plus water, potassium hydroxide plus hydrogen gas. So as you can see, quick comparison because it's Li and A and then K. Going down the group, the reaction gets more violent. So you can see from the lithium, it just fizzes and it floats around the water. But as you go down, like with potassium, it just burns and bursts into flame. So yeah, again, like I said, lithium hydroxide, sodium hydroxide, and potassium hydroxide are all alkalis.
Now we'll be skipping on over to the group 7, also known as halogens. Okay, so group 7, they are generally diatomic except for s atomic. So diatomic means they have 2 atoms, monoatomic, 1. We'll get to those who are having monoatomic form, but group 7, they have diatomic 1. Going down the group, opposite to group 1 alkali metals, here the boiling point increases and their density increases while reactivity decreases.
Okay, so the appearance of the halogens, basically when it goes down the group, it gets harder and darker as well. So chlorine in room temperature, this is all in room temperature by the way. Chlorine is a pale yellow-green gas, bromine in room temperature is a red-brown liquid, and iodine is a gray-black solid. So as you can see, it's going down, it gets harder and it gets darker as well in color. And for the displacement reactions, basically, since reactivity going down the group, it becomes less reactive, unlike alkali metals. So the more reactive element displaces the less reactive element. So in the PPT, when you can see, there is fluorine, chlorine, bromine, and then iodine. So the more reactive one is basically the front, and going to the right, it's less reactive. So for example, the Cl2 plus 2 KBr, the products would be 2 KCl plus Br2. The reason why is because potassium will basically get the chlorine, which is more reactive than the bromine, so it produces 2 KCl plus Br2. This reaction is called displacement reaction. A halogen will displace a less reactive halogen to form a solution of its halide. So basically, yeah, the more reactive one, basically the one going upwards is the more reactive, will replace the one downwards.
Alright, so now we'll be going on to transition metals. Now, metals between the group of 2 and 3, examples, copper, nickel, iron. You see there's a more shallow area over there in the periodic table.
All the yellow ones.
Yeah, the yellow ones, they are known as transition metals. Transition metals, they form ions, meaning they have more than 1 oxidation numbers. Example, let's get to copper. Copper, they have Cu plus and there's also Cu2 plus because they don't have a specific spot in the group. Therefore, their ion or charges aren't set or constant or permanent.
Basically, there are no trends in transition metals. There are no
Yes.
specific trends for their valence electrons and for their the charges they make, like the oxidation number.
And also their physical properties. They're high in density, they're hard and strong, high melting points, good conduction of heat and electricity. So if you notice, there are a lot of, for example, vehicles such as airplanes and cars made by transition metals such as iron, nickel, copper. And after, there are the chemical properties. They're much less reactive than the group 1 alkali metals. Does not show any trends in reactivity, and they most form colored compounds. Like group 1, they form white compounds.
Unlike group 1, they form white compounds.
Unlike group 1, they form white compounds. Many transition metals and their compounds act as catalysts, used to speed up reactions without changing them themselves.
Okay, so for the group 8, the noble gases, this is one of my favorite groups actually because they're very simple to memorize. So they have a full shell of electrons or no valence electrons. Because they're group 8, mostly they have 8 electrons, so like completely electrons. They're unreactive again because of the full shell of electrons and monoatomic gases. So if you notice the group 7, the halogens one, Michelle said it was diatomic. So usually they will be written like the element and then with a subscript of 2. While these ones, since they're monoatomic, they just exist as in like one atom. So again, noble gases have either duplet or octet structures, meaning a complete shell of electron. So everything has a octet structure except for helium because they only have 2 electrons. But still a complete shell of electrons because usually the maximum capacity of the first electron shell is only 2 electrons. And again, you can see in the image here, the noble gases shown are at the end of the periodic table. They're very right on the side of the periodic table. Okay, that's all from us. I hope you enjoyed our video.
And we hope our simple explanation gets you an A on your 10 and hopefully you understand more about the periodic table. Now,
You sure about the 8? Are you sure about
don't expose me like that. Anyways, I gotta go get a little of these sandwiches.
the 8? Not sponsored.
Bye.
Bye.